Hi, my name is Josh Wilson, and I'm a sophomore here at Houghton College, and I'm majoring in applied physics.
And I'm Adam Brown. I'm also a sophomore here at Houghton, and I'm majoring in physics and math.
This semester, we're both working on a project with Dr. Hoffman to build a scanning tunneling microscope, or STM. In previous years, students have worked on building an atomic force microscope. However, this year, we decided that building an STM might be a better approach. So we are the first two to work on this project, and we're building the STM from scratch.
So basically, what a scanning tunneling microscope is it's a machine capable of imaging individual atoms. And it uses a property called quantum tunneling. The basic principle of quantum tunneling is the closer two objects are to each other, the more likely an electron is to move between them. So for an STM, we move a scanning tip extremely close to a sample and measure the current that arises from quantum tunneling. In doing so, we can map out the layout of individual atoms.
So for the scanning head of the STM, it will have 3 threaded rods, each of which will be connected to a stepper motor. This allows us to do a coarse adjustment of the scanning head and tip close to the sample. For fine adjustments, we'll have the scanning tip here attached to a piezo buzzer with the electrode cut into quadrants. And by supplying a voltage to each of the quadrants, we can precisely move the scanning tip within nanometers for a more fine adjustment.
And so for the larger design of the project, basically what the frame is going to look like is a series of concentric rings that'll suspend the sample stage and the scanning head. And so we'll have a series of springs connecting each of the rings with a resonant frequency of 1 Hertz so that it'll cancel out any vibrations that might be interfering with the scanning of the sample. We'll also add magnets to the frame in order to provide eddy current dampening so that the stage and scanning head will move as little as possible.
And using the data of how the scanning tip moves and across the sample, we'll use it to visualize the individual atoms as well as the molecular structure of the sample on the atomic level. We hope to be finished building the entire STM setup by the end of the semester, and hopefully by the end of this academic year, we will be visualizing atoms and the atomic structures.
All right, that's our project.